How do we represent motion on a sheet of paper? Apart from writing on it, that is. A cartoonist might add some speed lines like this, but a scientist uses a graph. For the exam, you need to know about two types of graph: distance time graphs and velocity time graphs. First, let's look at distance time graphs. These graphs can be used to represent a journey. And we're nearly there yet. The vertical axis shows the distance travelled from the start point. The horizontal axis records the time. All we need now are the journey details. So here's me on my bike, and I set out from where I live. Might only have one door and a chimney, but it's home. And I'm on my way to visit my gran. I spend half an hour at my gran's eating cake, chocolate, mint imperials, cough sweets, and all those cake bars that are neither cake nor chocolate, but somewhere in between. My distance from home doesn't change during that time. Then I come home, experiencing quite an intense sugar crash, but not a bike crash, obviously. I'm just riding a lot more slowly. So what can we learn from a distance time graph? The slope of a graph tells us a great deal. If the line is horizontal, then no distance is travelled, so the object must be stationary. If the line of the graph is sloped but straight, then the object is moving at a steady speed. I came back from my gran's less quickly than I went there. With that much cake on board, you're going nowhere fast. The line sloped more gently when I moved more slowly. Now, on to the second type of graph you need to understand: velocity time graphs. Yes, those don't look like speed lines, do they? Let's just stick to the science. On a velocity time graph, the vertical axis is velocity and the horizontal axis is time. Now here I am taking Gran to the seaside. Spain, in fact. She likes the, food. Here is my speedometer. Okay, it's not my speedometer. No way, it's my story. Let's say I'm the pilot. Takeoff. Our speed goes from 0 to takeoff speed pretty quickly. I'm quite a smooth operator when it comes to my job. We keep accelerating as we climb. Then, we're at a nice steady cruising speed. Autopilot on. I pop back and chat to Gran, but she's watching Kung Fu Panda. So I try and chat up the stewardess. Hey, ladies. Great takeoff again, yeah. Whatever. Now, there's no acceleration going on. And notice what's happened to the graph. It's a horizontal line. But we are certainly still moving. That's a big difference between velocity time graphs and distance time graphs. And coming to land, we decelerate. So what does a velocity time graph tell us? A horizontal line means there is no change in velocity. Be careful, it doesn't necessarily mean the object is at rest. If we have a sloping line, then we have a change in velocity. The object is accelerating or decelerating. The steeper the line, the greater the acceleration or deceleration. And another thing, in distance time graphs, if the line goes back to 0, it means we have returned to the starting point. But in a velocity time graph, returning to 0 just means we've stopped moving. We're certainly not back at home. Before we finish, you need to know a few facts about working out speeds and accelerations. Let's first recap some basics. You can work out speed if you know how far something has travelled in given time. For example, suppose a car travels down a road 300 metres long and it takes 20 seconds. Its speed is how many metres it's travelled each second. So its speed is 300 divided by 20. That's 15 metres per second. If the car covered the same distance in 30 seconds, it would be going more slowly, and in that case the speed would be 300 divided by 30, which is 10 metres per second. So speed is distance divided by time, as in metres per second or miles per hour. Acceleration is the change in velocity in a given time. Suppose a car accelerates from a rather gentle 5 metres per second to a scarily fast 35 metres per second, and suppose this speed up takes only 10 seconds. Not only is this a pretty nifty car, the driver must be a mentalist! The change in velocity is from 5 to 35 metres per second, so an increase of 30 metres per second, which took 10 seconds to accomplish. So it increased its speed by 3 metres per second for each of those 10 seconds. Or, to put it another way, the acceleration is 3 metres per second. Or, you can say, 3 metres per second squared.